Hello everyone, myself Dr. Nagaraju. I am working as an associate professor in Department of IT, MLR Institute of Technology, Hyderabad. In this session, we are going to discuss about thread synchronization. First of all, why we are using this synchronization? Assume we have some shared resource. Shared resource in the sense the resource that is utilized by more than one process or more than one thread. I have two process. My example, assume I have two process P1 and P2. If both the process uses the same shared resource at the same time, what happened? Definitely the results will be changed. Why? Suppose P2 wants the original value. In meanwhile, P1 update the value, P2 gets the updated value but assumes that this is the original value. So the results are completely modified. In order to avoid such type of problems, we are moving into synchronization. Now what is the synchronization? It provides control the accessing of the shared resource. Controlling the accessing means, suppose in case of threads, after completion of one thread, next thread is allowed for accessing. That means more than one thread at a time not accessed the resources. Clear? That is achieved by using synchronization. Now, in Java, the synchronization is achieved in two ways. First one, mutual exclusive. Second one, cooperation, also called as inter-thread communication. Before explaining this mutual exclusion or inter-thread communication, first you need to understand what happened if you are not followed synchronization. I will show you with one example. A simple example. Create one class sample. Within the class, I return one method void display. What is my intention here? The display method is marked as a shared memory or shared resource. That means in my example, I create two threads. The two threads uses the display method. What happened if you are using synchronization without synchronization? Okay, clear? Void display into summan. Within the display method, I am writing for int I is equal to 1, I less than or equal to n, I plus plus. Now, just to print the value, system.out.println. I am just printing whatever you want, you can write. That is not a problem. N into I. Now, so to understand step-by-step execution, what I am writing, here I will write some sleep method. Thread.sleep. So what happened sleep? Whatever you return 1000 milliseconds, the execution stops. 1000 milliseconds, that is 1 second, the execution stops temporarily. So try, if you have a try method, compulsory followed by catch method, exception E, system.out.println E. Right, close the catch, closing of the for loop, and close of the display, and close of the sample. Clear? Now one class is created. Now what is your aim? You need to create some multiple threads. In this example, I am creating two threads. Class my thread 1. So how do you create a threads? You can use extends thread class or by using implementing runnable interface. Whatever you want, you can do. Here in this example, I am writing extends the thread class. Now, while extending the thread class, what is the procedure you need to follow? Create a constructor. Within the constructor, initialize an object for the class from which you are using the resource. Now I am using the resource from the class sample my thread 1 of sample s. This dot s is equal to s. Okay. Now any operation is performed in run method only. Any operation. So whether calling, execution, whatever you want, you can do inside the run method only. Now in the run method, what is the operation I want to do? I want to access the shared resource. What is the shared resource? Display s dot. I call the value with 5. Now run method is closed. Close this one. Now one thread is created. Exactly in the similar way, I am creating one more thread. So see what I am doing. This is my thread 2. I am creating the thread sample s. So my thread 2 s dot display, to avoid confusion. Here I called with the value 10. Okay. Now two threads are created. Next step is create a class demo thread synchronization. This is my class name. To avoid confusion, I used the entire class name demo thread synchronization. What is the first step? As usual, public static void main within the main. First to create an object for the sample class, new sample. Now create an object for the thread class. Create an object for the thread class. Now my thread 1. Some t1 is equal to new my thread 1. Within this one, so whenever you are created my thread 1 constructor is executed, the constructor consists of a reference s. So here you are passing this object ob. This object ob. Similarly, create an object for second thread, my thread 2. Some t2 is equal to new my thread 2 of. Okay. Two threads are created successfully. Now what is the step? You need to call t1 dot start. So starting of thread 1, t2 dot start. Starting of thread 2, close the main, close the class. Now observe in this example. In this example, I am not using any concept of synchronization. I am not using anything. Just one display method is there. T1 uses the display method. Thread 2 also uses the display method. Here I am not using anything. Okay. Save demo synchronization.java. Now Java C space demo synchronization.java. So no errors, fine. Java space. Now observe the output. According to our example, first to T1 is executed. What is the n value I given? 5. 5 into 1. 5 into 2, 10, 15, 20, 25. Followed by 10 into 1, 10 into 2, 10 into 3. That is actually our aim. But observe the output. First to 5, 10, 20, 10, 30. So output is in the correct order or not? 100% it is not in the correct order. So that means you are not using synchronization. It is not possible to get the output. Observe the previous one and this one. The output may be changed each and every time of execution based on the resources. The output may be changed also. Now, what is your aim? To avoid such a problem, we are moving into thread synchronization. Coming to first technique, mutual exclusion. The mutual exclusion means simply locking. So locking of the resources. Here locking is applied to either a class, locking to apply to object means all the instance members, locking is applied to a specific member. Once for a particular method, assume a method. If you apply a lock on a method, only that thread is allowed to use. All the remaining threads needs to wait until their completion. Now, here we achieve mutual exclusion in three ways. The first one is synchronized block. This is also called as object lock. So, what is the synchronized block? Here, the locking is applied to an object. The locking is applied to an object. See, this is the syntax. Synchronized of object reference means to which object you are applying synchronization. Means all the instance methods for that objects are locked. Suppose if you return this one in thread 1, until completion of thread 1, remaining all threads needs to wait. Remaining all threads needs to wait. So that is only the problem also here. The advantage is ambiguity is avoided. But what is the disadvantage? Object locking means all the methods under that objects are locked. For example, I have display 1, display 2, display 3 method. Only display 1 is a shared. But if you apply synchronized block, these 2, 3 are also locked. No one is allowed to use. Okay. Now, how do you write the synchronization? Observe, I will modify the program here. Display method. Within this, while calling the shared resource, you need to write like this. Synchronized of yes. Now observe what I written. Synchronized of yes means I am applying a lock on the object yes. Object yes. Whatever the instance methods that are available under object yes are locked. Now I written the same thing in thread 2 also. Now what happened? First you are starting thread 1. Whenever you start thread 1, so this is executed. Once this is executed, a lock is applied on thread 1. Now, the thread 2 is not at all entered. Now, I will show the execution, then you will get clear idea. Now, observe first to 5 table. 5 into 1, 5 into 2, 5, 3, 5, 4, 5, 5. Once it is completed, next to 10, 20, 30, 40, 50, 60, 70, 80, 90 and then 100. Now you got it? After completion of the first thread only, second thread is allowed. That is synchronized block. Suppose here you changed the order. T2 dot. At the same time, you understand the sleep method. Directly output is at a time not displayed. Each and every iteration 1 second is waited. Observe. First thread 2 is started. After completion of thread 2 only, thread 1 starts its execution. Observe the output. Thread 2 is going on. Now starts thread 1. T1, T5, 10, 15, 20, 25, 30. Close. You got it? This is synchronized block. This is one way of achieving synchronization. But what is the problem? Just now we discussed the entire object is locked. Even though there are no shared resources under the lock, but those are not possible to use by the remaining. Now, to overcome that one, we are moving into synchronized method. Means here the lock is applied only to the method. So, to which method is the shared memory? That is shared resource. The lock is applied only for that method. Now, what happened? I have 3 methods. 1, 2, 3. only 2 is the shared. Now lock is applied to this one only. This one and this one are free to use for anything. What is the syntax? Before the method, use the synchronized keyword. If you use the synchronized keyword, automatically that method is the shared. Now observe here which method you are using shared. Display method. Now what I am doing, before that method I written synchronized. Along with you can have non-synchronized methods also, not a problem. Now remove this one. Save. Now execute. Observe, first I call T2. So the complete thread 2 is executed. After completion of thread 2, we are moving to thread 1. This is synchronized method. Synchronized method. Clear? So what is the advantage? Instead of applying lock on all the objects, we are applying lock on the only shared resources. That is only shared methods. Now move to the last one under mutual exclusion. Static synchronization. The name specify class lock and static belongs to class. Means if you want to apply the synchronization to static programming components. Static programming components. This static synchronized is applied. See, all the static components within the class will be synchronized. Here the method must be, just for example, I am writing one static method, apply synchronization on the static method. Now show with an example. Stat. Here I am converting this method as a static method. Now apply the static synchronization in this. These steps are required or not required? 100% these steps are not at all required. Why? Here no need to create an object. By using the class name only we can access. Yes or no? Why? This is a static method. The static methods are accessed by using class name. Similarly, here also no need. Here instead of object, class name. Now, no need of creating an object. Remove this OB also. Save. First to thread 2, according to my example, I written T2 dot start. So thread 2, after completion thread 1. Now you observe the difference. You can apply the locking to instance method or static methods also, or apply the locking to the complete object, that is all the instance methods at a time. So these are the different ways of achieving synchronization with mutual exclusion. Remember, we are applying mutual exclusion in a block, mutual exclusion for a method, mutual exclusion for all the static components. Clear? Now, in the next session, we will discuss the achievement of synchronization by using inter-thread communication. That is another way to achieve synchronization. That is the end of today's session. Thank you.